Hi, this is Mrs. Slater, and before we start modeling with linear functions, I need you to get your note sheet out and also your graphing calculator. Okay, so with the first problem that we want to go through, it has been found that certain running records have changed with time according to linear functions. In 1920, the record for the 100-meter dash was 10.43 seconds. In 1983, it was 9.93 seconds. Okay, we're going to let R represent the record in the 100-meter dash at T, the number of years since 1920. All right, step one, anytime you are given any type of data, look for ordered pairs. So you can already see in 1920 would go with 10.43 seconds. As it says in the last sentence, let R represent the record, which would be above the Y coordinate, and let T represent the number of years. So this above the 1920 is going to be our T value for time. Okay, the next ordered pair that you notice is 1983. It was 9.93 seconds. So again, the time is going to be the X values and the record is going to be in seconds, and that's going to be the Y value. Okay, now it does say since 1920. So what that means is we can work with smaller numbers. For example, the ordered pair 1920, 10.43 is now going to be 0, 10.43. That 0 is just going to represent the beginning of the data that we are collecting. And again, to use smaller numbers, it will be nice too. Beginning of data. Okay, and then the second ordered pair is going to represent how many years later. So to find out how many years later, we can take 1983 and subtract 1920 to get 63 years later. The time had went down to 9.93 seconds. Okay. So once you have that established, now we can go ahead and predict some kind of linear function that fits the data. At this time, go ahead and get your calculator turned on and go to Stat. And I'll show you at the same time here. Go to Stat, and it should look like that. And then under Edit, so it is already there, we're going to push Enter. And then you're going to get list 1 and list 2. List 1 is going to be the 0 and the 63. List 2 is going to be the Y coordinates. So let's go ahead and type those in. 0, enter, 63, enter. And then you can arrow over to the next slide, to the next list, 10.43, enter. And then 9.93, enter. Double check to make sure you haven't made any errors, and then go back to Stat. So I have written down the steps on the side. You may want to take a second to pause the video and write those down. We first went to Stat, then we edited the list by putting the values in, and then we go back to Stat again, and this time we're going to go to Calc. And under Calc, number 4 on the list is called linear regression. It'll take these 2 points and set a line that'll go through both of them. So we're going to go to number 4, which is linear regression. That should show up next. And then when you push Enter, all the values that are in for the list creates a line for you. So let's go ahead and write that down. This form should look familiar because we have already talked about how y equals mx plus b is a standard form for a line, or it's just the slope-intercept form. So you can see the similarities. A and m are going to represent the slope, and the b is still going to represent the y-intercept. So when you get the information from your calculator, you should write the linear function as given. So y equals negative 0.0079. Always go to 4 decimal places. That should be a good estimate. And then x And then the 10.43 is going to be your y-intercept. And that is called a linear function that fits to these set of data points. Okay, so now step 3, we're going to make predictions. Predict the record in 2005. In order to predict this, we need to be able to figure out how many years later than 1920 2005 is. So just a simple subtraction problem will help you with this. And when you subtract, you get 85 years later. So that means we have been using years for the x-coordinate. So in our prediction equation, which is above here, we're going to use y equals negative 0.0079 times 85 plus 10.43. Okay, so in the calculator, we are going to clear that out and put negative 0.0079, multiply that by 85, and lastly we're going to add 10.43. And I see I forgot a decimal point, so I'm going to put that in real quick. And there we go. Okay, so what that means is that the record in 2005 should have predicted to be 9.7 or 9.8 if we are rounding correctly. 9.8 seconds approximately. Okay, so I want you to push pause and go ahead and predict the record for 2050. So hopefully you all got 9.403 seconds. Push pause and check your work. Next, we're going to find out in what year will the record be 9 seconds. So we are switching the question around. Now we are trying to find the x value given the y value. So this is our unknown. When is it going to be 9 seconds? So in the equation above that we have been using for all predictions, instead of replacing an x, we're going to erase the y, and we're going to put a 9 in its place. Okay, and then you would just solve for x by subtracting 10.3 from both sides and then dividing both sides by negative 0.0079. Go ahead and give it a try. Push pause. So if you got it correct, it would be 181 years, and what that represents is years later after 1920. So when you take 1920 and add 181 years, you get in 2101. That is the year that it would get down to 9 seconds. The next problem is about a chemistry experiment generated the following temperatures for a solution over time. Here's the time, so this is going to be our x value, and here's the temperature, so it's going to be our y value. So if you notice, in step 1, I'm asking you to look for ordered pairs. So the ordered pairs would be 5, 75, 15, 130, and so on. And 30, 200, and 32, 210. Now the reason you have to notice that is because any list and any ordered pair, we can figure out the best fit line. It may not be exact, like you may get something like this, but we can represent it because it's going in a positive line. So let's use our calculator to find the linear function. Push pause, go to your list. You may have to go back to the previous screen or the previous notes and look at stat edit and go back to those again. So push pause, and I want you to enter the values just as we've done before. So after plugging everything in, you end up with a linear regression where it looks like y equals y equals ax plus b, where a equals 4.9372, that is rounded, and b is 52.3449. Okay, so when you are finding the linear function, you should write it y equals 372 x plus 52.3449. Now we're going to use that in our predictions. Okay, so when we start our predictions, there are a few things we have to remember. One, that x is the minutes and y is the temperature. So if they're giving us 8 minutes for this one, we are going to plug it in for the x value. So go ahead and push pause and solve for y so we can do a prediction on the temperature. The answer is 91.8425 degrees, or approximately 92 degrees Fahrenheit. Make sure you're labeling along the way. This time they're giving you 60 degrees Fahrenheit, so they're giving you the y value. So you'd have to plug it in for y. So 60 will equal 4.9372x plus 52.3449. And go ahead and push pause and solve. So hopefully you got an answer of 1.5505. Again, that's approximately. So that is how many minutes it will take for the temperature to reach 60 degrees. And that concludes the lesson for today.